Number 1, if x minus 1 divided by 3 equals k and k equals 3, what is the value of x? So looking at this problem, there's a couple different ways to solve it. The first thing I see is that I have an equation here, x minus 1 divided by 3 equals k, and then they tell me what k is. So I'm just going to substitute that in there. So I have x subtract 1 divided by 3 equals 3. And two options right here. If your algebra is pretty strong, you just go ahead and you solve it for x. Another option is to plug the answers in. So I'm going to start with the traditional option first. I want to get that x minus 1 by itself. Whenever you have a big fraction like this, you have stuff on top in the numerator, and it's all divided by a number. The first thing I want to do is clear out that bottom number, clear out the divide by 3. So I'm going to multiply this side by 3, which multiply and divide cancel out. I multiply the other side by 3, and I get x minus 1 equals 9. And then my last step is I'm going to add the 1 to both sides. So add 1, and I end up with x equals 10. So the correct answer would be D. Now another option would be, if your algebra is not very strong, you have x minus 1 divided by 3, and I plug the 3 in. I could just start trying numbers. Normally, if I'm going to try numbers, I always start in the middle, because a lot of problems where you can try numbers, they tend to put the answers towards the bottom. So me personally, my strategy is, if I'm ever going to just plug in answers, I always start with C, because it seems like more of them end up being down there in the bottom two. So for this one, you might plug the 9 in for x, and you would have 9 minus 1 divided by 3 equals 3, and then you have to just test it. Well, 9 take away 1 is 8, and 8 divided by 3 does not give me an answer of 3. So I know that this one doesn't work. And I would try the 10, 10 take away 1 divided by 3. Well, that's 9 divided by 3, and that one does work. So then I would know that 10 is the right answer. Although I think on that one, the traditional route would be much faster for that problem. All right, number 2 here brings in imaginary numbers, but it's not too bad of an imaginary number problem. So they say for I equals the square root of negative 1, and there'll be another video that kind of breaks down imaginary numbers in a little bit more depth. But for this one, it says, what is the sum of the quantity 7 plus 3i plus negative 8 plus 9i? You can really treat the i's here just like any variable. So if I want to add these together, I can just drop the parentheses because there's no number outside here to distribute. Same thing with the plus, that's just considered a positive 1. So when I distribute that, I get negative 8 and plus 9i. And then in this expression, there's no equal sign, so I'm not solving the equation. I'm just combining like terms. And I have a positive 7 and a negative 8, so that comes together to make a negative 1. Then I have a plus 3i and a plus 9i, which is a plus 12i. And that one basically looks like it matches up with part A. Now another method that some people like to do, like for instance, this is kind of a little thought bubble, but if somebody said, hey, what's 58 plus 45? Normally I would stack those. I would do 58 plus 45 and stack them, and get 13 and carry and do it that way. So another way to do this problem, if you don't like going horizontally and combining like terms, you could stack it up and say 7 plus 3i added to negative 8 plus 9i. And it might look a little bit easier visually for you to stack them. So 7 plus a negative 8, that's negative 1. Positive 3 plus a positive 9, that's plus 12. And you'll get the exact same answer by stacking them. So a couple different options there. Number 3 here, on Saturday afternoon, Armand sent M text messages each hour for 5 hours. Tyrone sent P text messages each hour for 4 hours. Which of the following represents the total number of messages? So total normally means I'm going to add, so that's kind of a keyword that helps me out. So I know I'm going to be adding. Armand sent M messages every hour for 5 hours. So you're going to take the 5 hours and you're going to multiply it by how many messages he sent each hour. And Tyrone sent P messages every hour for 4 hours. So you're going to do 4 hours multiplied by the number of messages he sent. So, the answer is C. That's what represents it. Another way to kind of do this would be to pick your own numbers. Think about, well, how many text messages maybe do you send each hour? So, I don't know, maybe you send 7 text messages per hour. So if you kind of think about Armand and you say, well, if he sends 7 texts per hour times 5 hours, that means he sent 35 texts. And then if you think of, somebody else, if you don't have a friend named Tyrone, think about your sister or your friend or your buddy or somebody else. And you say, all right, this other person, maybe they send way more than me. Maybe they send 10 every hour. So they're sending 10 every hour times 4 hours, which would be 40 texts. So the grand total between those two would be 75 texts. Now, you chose your own numbers. You chose 7 for Armand, and you chose 10 for Tyrone. And Armand was M, and Tyrone was P. So what you could do is you could go over to these equations over here, and you could plug in the number you chose for M and the number you chose for P, and look to try to get an answer of 75. Now this would take a little bit longer, but it would definitely work, and ultimately you want to get problems right. So if I put these in here, if I look at A, that would be 9 multiplied by the 7 you chose, multiplied by the 10 you chose, and man, that's 630. That is not 75. So that one can't be it. And then you'd say 20 times the M you chose and the P you chose, which would be even worse. That would be, 70 times 20. That'd be 1,400 texts. That's ridiculous. That's not there. And if you plugged it into C, it would work. I already kind of showed you that over here. But if you want to check this last one, 4 times the 7 plus 5 times the 10 and 28 and 50. That's close, but not quite. So another way you could do it is kind of pick your own numbers if you don't like the letters, if they kind of distract you. So I use that strategy quite often. Okay, number 4 here. Number 4 is a long one, so I'm going to skim it, but I'm actually going to try to pick out some key words. So Kathy's a repair tech for a phone company. Each week receives phones that needs repairs. The number of phones, so this is important here, the number of phones that she has left to fix at the end of the day can be estimated with the equation. So we have P equals 108 minus 23D. And let's kind of put what these things are. P represents the phones left. So that's how many are left to repair. And D is the number of days that she's been working on them. All right. And so what is the meaning of 108? So they're kind of asking me, what does this 108 mean? Well, really for me to figure out what it means, I might make a little T-chart. This is kind of the first thing that pops to my mind, is maybe make a little table and let's just kind of figure out a couple numbers. We don't have to go very far to at least see what the numbers represent. So I always start at 0. At 0 days, when I plug 0 into this equation, I have 108 minus 23 times 0, which would just come out to be 108. So basically it looks like when there's 0 days worked, there's 108 phones left. Then I could, and right there kind of answers my question, but I could go a step further. After she works 1 day, she has 108 minus 23 times 1, or 108, take away 23, which would be, what's that, 88 minus 3 more, 85. So that means after 1 day of working, she has 85 phones left. And then the pattern kind of just keeps decreasing by 23 each time. So this would be 62 phones left. And we could actually figure out how long it would be before she's finished with all the phones. But I think I've answered my question. What does the 108 mean? Well, the 108 is how many phones she started with at 0 days. So we don't know how many days she's going to complete it. We haven't taken our chart out far enough for that. But I believe B, she starts the week with 108 phones left to fix. Sometimes it's very tough to see what the numbers represent unless you draw a picture, make a table. You know, when I do an SAT test, I have so much scratch work and scribble all over the place. You got to get a picture of this stuff before you can really see what's going on. Okay, looking at number 5 here. Which of the following is equivalent? So equivalent means equal to. Which of the following expressions are equal to the expression above? So a couple different ways to do this. I noticed there's some parentheses. In this first parenthesis, there's an understood 1 there. So distributing a 1 basically does nothing. So I'm just going to copy down that first part. X squared y minus 3y squared. Notice how I spaced these out a little bit. This kind of helps me keep track of who are the like terms. Now this minus is very important. This minus I treat like a negative 1. And basically I distribute that negative 1 all the way through. And all it really does is it changes all the signs to the opposites. So this negative x squared y becomes positive x squared y. This positive 3xy squared becomes negative 3xy squared. And then the negative 1 times the negative 3y squared becomes positive 3y squared. So basically I have 1, 2, 3, 4, 5, 6 terms, and now it's just a matter of gathering up my like terms. The exponents in the letters have to match perfectly. So if I have an x squared y, I can only put that together combined with other x squared y's, which is right here. And there's kind of an understood 1. So together that makes 2 x squared y's. Looking at my answers, I like to kind of peek at my answers right now and eliminate people that do not have a 2x squared y. So A and B are now eliminated. So worst case scenario, I at least have it down to a 50-50. But let's keep going. I have a negative 3y squared and a positive 3y squared. Those cancel each other out. So they're gone. And then finally, I have a positive 5xy squared and a negative 3xy squared. So positive 5 and negative 3 give me positive 2xy squared. So I believe the correct answer here is C. All right, I would like to show you another way if you don't like doing it horizontally or distributing. You know, if somebody just asked me, you know, hey, what's 93 take away 59? I wouldn't do it horizontally. I would probably stack it up and say 93 minus 59, and I would do it kind of like you do in elementary school, and I would borrow. So you can do the same thing here if it helps. So I'm going to write the first one, x squared y, negative 3y squared, positive 5xy squared. I like to look at things as positive and negatives and not always as subtraction and addition. I believe it helps. And then I'm going to subtract, so I put a subtraction sign here. And then I'm going to stack the next parentheses and make sure I line the families up. So for instance, I have a negative x squared y. That's going to go right here, negative x squared y. This 3xy squared goes over here, positive 3xy squared. And then I have a negative 3y squared, and I'm going to put negative 3y squared. So notice that everything is lined up in columns. The like terms are lined up. And now I can just treat it like one big subtraction problem. You know, be careful to know that these are ones. So 1 subtract a negative 1. Well, 1 minus the negative 1 is 2. A negative 3 subtract a negative 3. Well, subtract a negative really means plus. So these two basically cancel each other out. And then I have a 5 take away 3, which is positive 2xy squared. So that's another way to do it without distributing, is you can stack the two terms on top of each other. Number 6, we have h equals 3a plus 28.6. Looks like we have a linear expression here. Let's read about it. A pediatrician uses the model above to estimate the height of a boy. So h represents the height. What are our units? Looks like we're looking at inches. So height in inches. In terms of the boy's age, so a represents the age in years. Between the ages of 2 and 5. So if you're younger than 2, older than 5, this model does not work. Based on the model, what is the estimated increase in inches of a boy's height each year? So we're trying to figure out how much they're predicting he's going to grow each year in inches. One way to do this would be to set up a table. This might be the longer way, but I'd still like to show it because some problems I'm not exactly sure how I'm going to solve it. So a lot of times I'll go to a table or a graph or some sort of picture to make some sense of it. Let's start with a 2-year-old. So if I do 3 times the 2-year-old plus 28.6, that comes out to be 6, and that comes out to be 34.6 inches. So right there, we'd expect that. Let's move to a 3-year-old. So at 3 years old, that's 9 plus 28.6. That's 37.6 inches. So at 3 years old, 37.6 inches. Let's go one more. A 4-year-old would be 12 plus 28.6, which is 40.6 inches. And I think we can kind of see the pattern here. It looks like for every year the child gets older, all right, for every 1 year, the height increases by 3 inches every single time. So I believe the correct answer for this one is A. Now that's kind of the long way. If you are familiar with slope-intercept form, you could look at this equation and realize it's kind of in the same format as y equals mx plus b. And remember that the plus b represents the y-intercept, or a lot of times it represents your starting point. And then the m, the term that's in front of the x, represents the slope, also known as a rate of change. Positive slope, it's increasing. Negative slope, it's decreasing. So looking at this equation here, h is kind of like my y, and a is like my x. So when I want to know how much you're increasing each year, that's represented by the slope. So that might have been a faster way to kind of recognize that the correct answer was 3. But either way, as long as you get it right, it really is a personal preference. All right, looking here at number 7, this one looks pretty nasty. You got a lot of stuff going on here, and oftentimes when they look really nasty, there's some sort of a trick or some bigger structure piece to this one, and there's no surprise here. That's what happens. So you see m equals a whole bunch of stuff on top to the n power over a whole bunch of stuff on bottom to the p power. Says the formula above gives the monthly payment needed to pay off a loan, r percent, n months. I mean, they have a ton of letters there. But the most important part is right here. Which of the following gives p in terms of? So that means they want the answer to be p in terms of. Just treat that as an equal. And then they want m, r, and n over here on this side. So basically they could have just said, hey, solve for p. That's kind of what they're wanting to do here. So I look at this thing, and if I want to solve for p, I kind of look at the overall structure and I start peeking through the answers. And a lot of that stuff is kind of the same in the first few choices, A, B, and C. I could scroll down and look at D. But to me, it's kind of like this. M equals a bunch of stuff up here. Let's just call it triangle. M equals triangle over rectangle. And then all of it's multiplied by P. Well, pretend these were numbers. Pretend that you had M equals 2/3 P. And if I ask you to solve for P or get P by itself, there's a couple different ways you could do it. The old school way that I like to do is I would multiply by the reciprocal. I would multiply by 3/2, and I'd multiply this side by 3/2. And basically that cancels out so that I end up with P. And notice what happened. On this side, you just have the flip of what started over here. So that's all you're going to do on this one. If I multiply by the reciprocal, I'm just going to end up with P, and then everything on bottom is going to jump up top, and everything that was on top is going to jump down on the bottom. And when I look through the choices, it looks like that one is choice B. You know, this right here was the bottom of the original. This right here is the top. So, you know, if you kind of do it in symbols, basically to solve for P, you would multiply the left side by rectangle over triangle times M. And this side, you just have P left over. That's what will happen when you multiply by the reciprocal. So this is a problem that looks really nasty, and you get into there trying to do a bunch of algebra, and it's almost a trick question. So it's more of I call this a structure question. It's more of seeing the bigger structure and not really getting into all the little details that slow you down. All right, looking at number 8. Let's take a peek here. It says if A divided by B is 2, so we have to assume this part right here is true. If A divided by B is 2, then what is the value of 4B over A? Well, again, there's several ways to solve this problem. I'm going to show you my strategy that it's kind of my go-to when I'm not sure what's going on. And I call that pick my own numbers. I'm going to pick my own numbers, and I'm going to choose wisely. I'm going to pick numbers that are small, between 1 and 10. Usually my go-to numbers are like 2, 3, 4, if possible. But on this one, I just need to find two numbers that when I divide them, I get an answer of 2. So think of an A and a B that could divide out to be 2. You know, the first thing that jumps in my head is 6 and 3. So I know that 6 divided by 3 equals 2. So for this particular problem, I chose A to be 6, and I chose B to be 3. And now it says, what is the value of 4 times B divided by A? Well, let's use my numbers. 4 times B, my B, divided by A, and that comes out to be 12 divided by 6, which is just 2. So I believe C is the answer. Now, let's just double check and see if you would have tried a different set of numbers, if that would have worked. So I come back over here, and maybe the next thing that jumps into my head is 10 divided by 5. So as 10 divided by 5 is 2. So I chose 10 for A, I chose 5 for B. And now I do what they want. I do 4 times B divided by my A, and that's 20 divided by 10, which is again 2. So as long as you pick the numbers that start off by equaling 2, you should be in pretty good shape. You know, there's a couple different ways to do this problem. You know, another way that jumps into my head, and this is kind of more of a pure algebra way, but I could solve this first equation for one of the letters, maybe for A. So if I start off with A divided by B equals 2, and let's say I want to get A by itself, I'm going to go multiply by B to cancel that, and if I do it to the left, I have to do it to the right. So A is basically equal to 2B. And then I can go back up in this equation up here, and now that I know what A is, I could replace it or substitute it. So I have 4B divided by 2B, which also just comes out to be 2. So that's kind of a more traditional algebra way, but I'll be honest, a lot of questions on this test, I think you make fewer mistakes, and it's sometimes faster if you just pick numbers that can work for you. All right, number 9. I see right away I have two linear equations, also known as a system of equations. So systems of equations is definitely in the top 5 most occurring type of question on the SAT. There's usually at least, you know, a couple, 2 or 3 on the calculator and 1 or 2 on the no calculator, probably somewhere in the 4 to 5 question per test. So it's a pretty big chunk. There's usually a word problem as well. And if you struggle with this after I show you this example, there's another video I made on solving different types of systems of equations. You know, right off the top of my head, the ways you can solve these, you can solve them by graphing, which I wouldn't recommend. It's long and it's slow. My usual go-tos are elimination, and I use elimination in a situation like this where I have x's, I have y's, and I have numbers for both equations. Once in a while, I'll use substitution, because substitution works nice if one of the equations is already solved for a letter. So for instance, if one of the equations starts out y equals, or one of the equations starts out x equals, I'll use substitution. And that'll probably show up in another test somewhere. But I'm going to use elimination. This is usually the fastest, and it's my go-to method. So if you're going to use elimination, the most important thing is you need to get your equations lined up. And what I mean by lined up is you need an x column, you need a y column, and you need a constant or just a number column. And the top equation is exactly how I like it. I like it when it's 3x plus 4y equals negative 23. That's the traditional way to write it. The bottom equation's kind of backwards, so I need to kind of move people in the right places, and sometimes it means moving it to the other side, which I'd have to change the sign. This one I don't have to move anything to the other side. The negative 19 is on the right side, which is okay. But that 2y, I'm going to slide over here. Since it's positive, I'll write positive. And the x was negative, so I got to go negative x. And I even like to put a 1 there, negative 1x. All right, well now I'm ready to start getting after this problem. And the next thing I have to make sure, I have it lined up, but I have to make sure that the coefficients match up. And what I mean by match up is like they both either have to be 3s or one's a 3, one's a negative 3, or both the same. It really doesn't matter, but I need to get 3s there, or I need to get these guys to match up to be the same. And neither of them are matching right now. What I mean by matching is if I would have had an equation like 3x plus 4y is negative 23, and then if the next one would have been like 3x plus 2y equals negative 19, I would have had a match here, and I wouldn't have to do the step that I'm getting ready to show you. But I'm going to force these people to match. So what I'm going to do, and I have a couple choices, I can either get the x's to match or I can get the y's to match. I'm going to get these x's to match. So I'm going to multiply this entire row by 3. Every single piece on this row is going to get multiplied by 3. I'm kind of going to distribute it all the way through. So I'm going to copy down the first equation, 3x plus 4y. I'm not going to touch that one. I'm going to leave it alone. The bottom equation I'm going to multiply, and now I have negative 3x, positive 6y, and I got to multiply 3 by 19, which would be negative 57. So now I like to look at this as having a match. And I don't really care who's positive or who's negative. They could both be positive, both be negative. But I need to now eliminate the letter that I've matched. So now I have to make a choice. Do I want to add these two rows, or do I want to subtract these two rows? And the only way to make those x terms disappear in this case is to add them, because a positive 3x plus a negative 3x is going to disappear and they're going to be eliminated. If this was my equation, this wasn't the equation, but this is in my thoughts right now. If they were both positive 3x, I would subtract these two equations. All right, so we'll probably see that on a later part of this test or another test. But I'm going to go ahead and I'm going to add these rows up. So 3x plus a negative 3x is 0 x's, so they just kind of disappear. Now I have positive 4 plus positive 6. Well, that's 10y. And then I have a negative 23 plus a negative 57. So that's going to be a negative 80. And what I've done is I've eliminated x's, and now I can solve for y. So to solve for y, I divide both sides by 10, and I get y equals negative 8. Now, I look at my answer choices here. These are the x's, these are the y's. It looks to me like this is the right answer, and I don't really have to do any other work. If I didn't, if there was another one that had a negative 8 in it, the technical way I'm supposed to do this is I'm then supposed to take this negative 8 and plug it back in to either equation, either plug it in here or plug it in here and solve for x. So let me just show that. Let me just kind of get rid of some of this clutter here, and let me just show how you get the 3. And I'm going to get rid of all this, and I'm just going to keep my y equals negative 8. So I would go back up to either equation. I would probably pick this top equation because, I don't know, it just looks a little friendlier to me. It has maybe some less negatives. So I say 3x plus 4, and instead of writing y, I now know what y is. Y is negative 8 equals negative 23. And now I have one equation with one unknown, so I can solve that. 3x minus 32 is negative 23. I'm going to add 32 to both sides, and I get 3x equals 9. And now I'm going to divide both sides by 3, and I get the x equals 3. So now I have an x, I have a y, and typically we write that as an ordered pair, 3 comma negative 8. Now, I mentioned graphing earlier. Just to kind of give you a little heads up and a little bit of deeper insight on this. When I graph these two lines, and I'm not going to be too particular on what they look like, but when I graph these two lines, and I'm not even going to put the coordinate grid. I'm just going to draw two lines. Maybe this top line right here looks something like that, and maybe the bottom line looks something like that. Well, what I just found, this point, this 3, negative 8, is the intersection of those two lines. So I'm not going to get all into graphing these two because there's no grid available, and that would take me a long time to draw the grid. But I just want you to understand that what you just found was the x and the y that makes both equations true. And graphically, that's represented by their intersection. That's the point that lives on both lines. So, you know, it was kind of long, but I think as you do a few of these, you'll get faster and faster. I have some practice problems in my systems of equations video that you can kind of work with to build up your speed. On this problem, another way, and this could be time consuming, but another way that you could do this problem is you could just start trying every XY combination until you found the one that worked for both of them. I'm not going to do them all because of time, but I'll show you one that doesn't work. For instance, let's try part A. If I do my top equation, 3 times negative 5, so I'm plugging this number in, plus 4 times negative 2, does that equal, so I'm questioning, does that equal negative 23? Well, let's look at it. 15 plus a negative 8, does that equal negative 23? No, it doesn't. This is 7. Or actually, check that. Made a little mistake here. That's negative 15 plus negative 8. So that one does work. Negative 5 does work right here. Now, they want you to be like, oh, it works, so they want you to pick it. But remember, it's got to work for both of them. So now I'll try it here. 2 times the y value, so 2 times the negative 2, minus the x value, which is a negative 5. Does that come out to equal negative 19? So I'm trying it in the bottom equation now. Well, that's negative 4 minus a negative is plus 5. And that does not work. Negative 4 plus 5 is 1. 1 does not equal negative 19. So 5, negative 2 worked in the top one. It did not work on the bottom one. So then I would have to scrap that, and then I'd have to move down to the next one. Now that is actually a lot more time consuming once you get good at using elimination. So I don't usually recognize that method unless you're in a pinch and you have no other strategy to use. All right, so it looks like we are up to number 10 here. I see right away the notation's a little bit weird, and just recognize whenever you see this, this is called function notation. And, you know, let me just kind of break that down a little bit to you. So if you see something like, you know, maybe, and a lot of times they use the letter f, like f of x equals 2x plus 5. All right, well, then they might say if f of x equals 2x plus 5, an easy question might say find f of negative 3. Well, all that means is wherever you see an x, you're going to replace it with negative 3. So 2 times negative 3 plus 5 is negative 6 plus 5, which is 1. So f of negative 3 is 1. So you kind of interpret it as when x is negative 3, what's the answer? You know, that's another way of asking this. So I'm looking over here. The only thing I see that's weird is there's this extra a in there. So let's kind of see what that's all about. It says for the function g, so g is another letter they use a lot. For the function g above, a is a constant, which means it's just some number. And g of 4 is 8. So what I just did over there on the right, that's what I'm talking about. So they mean when they plugged 4 into this equation, they got an answer of 8. So let's kind of write this out. So g of 4 means everywhere I see an x, I put a 4 in, equals, still don't know what a is, but this is 4 squared plus 24. All right? And it looks like that came out to be 8. Now, the slick way to do this problem, the fastest way to do this problem is to realize, now they say, well, what about if you stick negative 4 in there? So g of negative 4 equals a times negative 4 squared plus 24. And we're trying to figure out what that equals, and these are my choices. Well, the one thing I noticed right away, and this is kind of a trick question, you know, I could figure out what a is from the top equation. And maybe I'll do that at the end, but it's not really necessary. Because if you look at this, 4 times itself is 16. But putting a negative 4 in there really did nothing. Because a negative 4 times itself is also 16. So as long as a is the same, which they said it's a constant, it's not going to change, I'm still going to have 16a plus 24 and 16a plus 24, which means the answer to this question should be the exact same regardless if it's 4 or negative 4 because of this squared here. So that was the big idea that they were trying to test. What they probably wanted you to do, because they want you to waste a lot of time and they want people to run out of time, is they probably wanted you to solve for a. So if I know that g of 4 is 8, so I know 8 equals a times 4 squared plus 24. They want you to try to figure out what a is. So we could do that. This would be 16a plus 24. And I would subtract 24 from both sides. Minus 24, minus 24. And I would end up with 16a equals negative 16. Divide, divide. And I'm like, oh, a is negative 1. Now, I didn't really need that. But if I went down that road, I could have used the 4 they gave me, used the 8 they gave me, solved for a, and then went and repeated it for negative 4. And say, okay, now that I know what a is, negative 1, and I'm supposed to stick a negative 4 in there and square it and add 24, what's the answer? Well, order of operations says I have to do negative 4 times itself. Do not multiply these two together. You can't do that. You got to do the order of operations. So this would be a negative 1 times positive 16 plus 24, which is negative 16 plus 24, which does end up being 8. So you could have solved it if you found a, but it really wasn't necessary. So if you saw that earlier, you might be able to save a few minutes. Okay, number 11. Looks like I have a couple equations up there. A b equals equation, I have an x in it. A c equals equation has an x in it. So I'm going to have to read to see what exactly they want me to do and what these letters represent. So it said B and C represent the price per pound in dollars of beef and chicken. So, this is my beef equation. This is my chicken equation. X weeks after July 1st, during the last summer. What was the price per pound of beef? So my focus is going to kind of be on this top equation. What is the price per pound of beef when it was equal to the price per pound of chicken? So at some point, for some certain x, the two prices are the same. Well, how I know when beef is going to equal chicken is when B equals C. That's when beef equals chicken. So now I'm just going to substitute. B is right here, 2.35 plus 0.25x. And when is that going to equal the chicken equation? 1.75 plus 40.40x. And I'm going to solve this, and that'll tell me when B equals C. So there's a lot of different ways to start this, but I like to start with the variables. So, and I always go after the smallest variable. So I see I have an x on both sides. I want to get all those x terms to one side. I'm going to subtract the 25 cents x, subtract the 25 cents x. I didn't put a 0 over here, but it doesn't really matter. So that goes away. I'm left with 2.35 equals 1.75, and 40 cents take away a quarter. That is a positive 15 cents. I'm going to leave the 0 out. It's just faster and less clutter. Now that I have the x's on the right, I need to get the constants on the left. So doing the opposite is minus 1.75 from both sides. And subtracting that, $2.35 minus 175, that is 60 cents. And over here I'm left with 0.15x. And now I think I can divide both sides by 0.15, divide by 0.15, and I get x equals 4. Now, normally you circle that and you're like, oh, there's my answer, x equals 4. Sometimes they'll put an answer over here of $4 and try to trick people. But really, I still haven't answered the question. They want to know, what is the price of beef? Well, I found the x when it happened. So now I have to come up here to the beef equation, and I have to put 4 in there. So B equals $2.35 plus 0.25, and now I know what x is. X down here was 4, so I replace it, and this isn't too bad. B equals $2.35 plus, that should have been a 4, and 4 times 25, that's 4 quarters, that's $1. And so it looks like the beef is $3.35, which would be choice D. So not only did you have to solve for x, you had to go back and you had to plug it in to find the true price. Now that's one method. That's a traditional algebra method. There is another method if you'd like, and basically you could run those two equations side by side. So here's another way. You could have the beef table, the chicken table, and then kind of the x table, and you could kind of run these out. And I like to use tables. To me, they kind of make sense, and I think maybe I better give myself a little more room because those prices have decimals and they're kind of longer. You know, the part about the table is you got to draw it, so that kind of sucks sometimes, but you got to do what you got to do. So I put my numbers in, and I say, all right, well, when x is 1, which means 1 week after July 1st, so, you know, a week after July 1st, I could plug 1 in, and if I plug 1 in up here at the top, that would be $1.75 plus 0.40 times 1, so that comes out to be $2.15. And then for beef, if I put a 1 in here, that would be $2.35 plus 25, that would be $2.60. So beef is more expensive 1 week after July 1st. Then I keep going. 2 weeks after, if I put 2 in both of those, if I put a 2 here, that would be 80 cents plus $1.75, so that'd be $2.55. And then if I put a 2 in here, 2 quarters of 50 cents, $2.35 plus 50, that's $2.85. And now I can kind of quit plugging numbers in and just cheat and look at the pattern. The pattern for beef is it's going up by 25 cents because that's the slope, that's the rate of change. So it's going up 25 cents. So this would be $3.10, another 25 cents, $3.35. If I wanted to keep going, another 25 cents would be $3.60. I'm about out of room. Checking if I keep going, it looks like it's going up by 40 cents each time. So that'd be $2.95, $3.35, $3.75. So this is another way to see that, you know, when beef and chicken were equal is right here. That's when they're equal. And it happened at 4 weeks after July 1st, but the price was $3.35. So if you don't like solving algebra equations, you probably could have sidestepped at that time and used the table. All right, number 12. A line in the xy plane passes through the origin, has a slope of 1/7. Which of the following points lies on the plane? So, you know, I'm thinking right away I might want to graph this one. just to kind of have an idea of what's going on. So I'm going to draw my coordinate plane, my coordinate grid. The x-axis is here, the y-axis is there. Little vocabulary word, the origin is right in the crosshairs or the center at 0, 0. So a line passes through 0, 0 and has a slope of 1/7. Well, remember, slope is the rise over the run. And if it's positive like this, you're going to go up 1 and over 7. Now, just kind of a side note, if the slope would have been negative 2/3, if it's negative, we would be going down 2, right 3 units. All right, but for this problem, it's positive, so we're going up 1, right 7. So I'm going to sketch that out. Up 1, right 1, 2, 3, 4, 5, 6, 7, and I'll put a dot right there. So there's my first dot of 1, 7. Now, which of the following points lies on the line? So right now, I have this little piece of the line, and I could keep going. You know, if I keep that same slope going, you know, if I go up 1 over 7, I'm going to go up another one over another 7. So if I go up another one, 1, 2, 3, 4, 5, 6, 7, that puts me out here at 14. So another point on the grid would be at 2, 14. And I keep going like that. And so I look through my choices and I say, well, which one of these points could be on this line? Why don't we just graph them? So 0, 7, remember when x is 0, y is 7, that would be right up here somewhere. You know, that would be 0, 7. So I know you're not on the line. 1, 7 means go right 1, up 7. So that would be right here. Nah, can't be you. 7, 7 would be over 7, up 7. Nope, can't be you. And finally, 14, 2. That means go over 14, up 2. Hey, I think you're the winner. I think you're on the line. To me, that's probably the most straightforward way of doing this problem. You could have probably, you know, came up with an equation. If you had to write an equation for this and using slope-intercept form, they give me the slope. So y equals mx. My b is my y-intercept, which, you know, I could write plus 0, but there really no need for that. And then I could go through, and since I now know the equation of this line, I could try all of these points. You know, I'll go back here and erase them. I could go back and see if these points satisfy the equation. Now this would take a little bit longer, but you know, I could plug all of these xy's in and see if it's true. So is it true that 7 equals 1/7 times 0? So I plug these two in, and that's false. That doesn't work. I could then check the next one. When y is 7 and I stick 1 in there, is that true? And that's false. 1/7 does not equal 7. And I could try it one more time. I could plug that in there. Does 7 equal 1/7 times 7? Nope, because 1/7 times 7 is 1, and 1 doesn't equal 7. And then finally, I would try the last point, which I think they wanted you to do it this way, because whenever you can plug numbers in, it seems like the bottom answer is the one, because they want to waste your time. So let's plug that one in. When y equals m, and then my x is 14, hey, that one's true. 1/7 times 14 does come out to be 2, so this was a correct answer. So you could have did it mechanically with an equation. I like the picture better. I think it's a little more straightforward for this one. All right, number 13. So we're getting into some of the tougher problems here. 1 through 15 are multiple choice, but you know, 11 through 15 is where it starts getting pretty gnarly. These problems take a little longer. They're a little rougher. So we got to kind of step up our game. And I'm looking at this one, and it says if x is greater than 3, so x has to be bigger than 3, which of the following is equivalent or equal to this expression right here? So they give me this big expression, and if somehow using algebra I can manipulate it and move it around, it should match up with one of these choices, A, B, C, D. I'm going to show you two ways. Me personally, if I'm under a time crunch, I'm probably going to pick numbers on this one. I'm not going to mess around and try to do a bunch of algebra. I think I can pick numbers. You have to be somewhat decent with your mental math to pick numbers on the no calculator section, because there might be fractions, and a lot of times I just estimate, and it usually does me pretty good. So first thing is, when I pick numbers, it says x has to be greater than 3. So why not 4? No, you can pick anything. You pick 20 if you want, but I'd rather pick smaller numbers. So I'm going to pick 4, and let's just see what comes out here. So if I stick 4 in there, I get 1 divided by 1 over, well, 4 plus 2 is 6, and then 1 over 4 plus 3 is 7. So here's kind of where you have a choice to make. You could get into trying to add those two up. You know, if you're really good with fractions, you could probably quickly add those together by finding a common denominator. The common denominator I would use would probably be 42. And you could say, well, 6 times 7 is 42, so I got to do 1 times 7. And 7 times 6 is 42, so 1 times 6 is 6. And you could add those up, and you're going to get 13 over 42. So this is what the bottom is. So when I look at this top, this is really 1 divided by 13 over 42. Now, if you're also good with fractions, you remember that when you want to divide by a fraction, you really never divide fractions. You always multiply by the reciprocal. Some people call that keep, change, flip. I've heard same, change, change. Lots of teachers have different jingles, but basically you keep the first number the same, you change it to multiply, and then you flip the second one. So 1 times 42 over 13 just becomes 42 over 13. 1 times anything is the thing itself. So this is the answer. That's the exact answer for this problem. So I need to now try my 4, my original number that I tried and I plugged in. I need to try that in every choice and see which answer is 42 over 13. So let's just do this. I start off with part A. If I'm plugging, if x equals 4, let's try it. Well, 2 times 4 is 8 plus 5, that's 13. 4 squared is 16 plus 5 times 4 plus 6. Well, that comes out to be 13 over 42. So it was close, but it's actually the reverse of what I want. All right? I needed 42 over 13, and they're telling me 13 over 42. So I know it's not A. But man, if I could get the reverse of that, I would be in good shape. Now, if you look at B, you'll notice that the top is what this bottom was, and the bottom is what this top was. So I don't even have to plug that all in again. I know this one is going to come out to be 42 divided by 13, which is a match for me. So I know the correct answer is B. And just to be sure, I'm going to plug my 4 in down here. 2 times 4 is 8 plus 5. That doesn't work. This is 4 squared plus 5 times 4 plus 6. This is a big old number. 16 plus 20 plus 6. So this one just equals 42. So that doesn't work. So I kind of cheated the problem by picking my own number and just plugging it in. Now, even if I wasn't very good at fractions and I didn't want to go through all this work over here, another thing that I could have done is I could have just estimated. I think the first time I actually did this problem, I estimated on it. So what I did, instead of going through all that stuff, I kind of said, well, what if this was just 1/6? That's pretty close. 1/7 is pretty close to 1/6. And I said, well, that's just 1 divided by 1/6 plus 1/6 was 2/6, which is 1/3. And I said to myself, what's 1 divided by 1/3? Well, that's really just 3. Now, I knew 3 wasn't the right answer, but I knew it was kind of close. It was about equal to 3. And so then I still stuck my 4 in all these choices. And I noticed these ones with the arrow were not anywhere close to 3. And I noticed this one, 13 goes into 42 3 times, which would be 39, with a little bit left over. And I said, well, this is pretty close to 3. So the very first time I did this test, I didn't even take the time to do the 42s and get the common denominator. I just kind of pretended it was 1/6. And the answers were so far apart, 13, 42, less than 1. It was kind of obvious to me. Now, if you understand that, you can kind of stop watching the video right now. But if you want to do it traditional, I don't want to shortchange the pure algebra people. So I'm going to take a second to walk you through the long way to do this problem. And it's kind of similar in that whenever you want to find a common denominator, a move that you can do is to get these common denominators on the bottom, I'm going to multiply this right fraction by the denominator on the left. So I'm going to multiply x plus 2 over x plus 2, which really is just 1. So I didn't hurt anything. I just multiplied something by 1. And I'm going to multiply this side by the other denominator, x plus 3 over x plus 3, which again is just 1. So I haven't done anything but multiply both sides by 1, but I did carefully choose the 1. Well, now when I write this out a little bit, let's clean this up. This left piece here, when I multiply across the top, x plus 3 times 1 is x plus 3. The bottom, x plus 3 times x plus 2, got to have a little bit of a review on multiplying binomials. A lot of teachers call this FOIL, where it's really double distributing. But I do x times x, which is x squared, x times 2, which is 2x. Then I got to do the 3 times the x. And then I got to do the 3 times the 2, which is 6. And that just comes out to be x squared plus 5x plus 6. That's a lot of work to get just this piece. Well, luckily, I get to use that again, because then I come over here. The top is 1 times x plus 2. And the bottom is those two times each other again, so I can kind of copy that. And then I have to be careful that when I move down, the top's still 1. Now I notice I have two fractions with the same bottom number. So I know when I add them together, the bottom number is not going to change. And the top I have to actually put together. So I have x plus 3 added to x plus 2. Well, that's 2x plus 5. And now, kind of using the trick I use with numbers, or not a trick, but whenever I divide fractions, 1 divided by 2x plus 5 over x squared plus 5x plus 6 is really the same thing as 1 multiplied by the flip of that, or the reciprocal of that. And 1 times anything just gives me the answer. Now, I'm tired even doing that. That was a lot more work than necessary. This was a problem where I think it was a perfect candidate to pick my own x, stick it in there, get some real numbers, and see which one it's equivalent to. That is one of my best go-to methods that I use to kind of cheat the SAT. All right, number 14. We're getting to the second to last multiple choice one here on the no calculator. So I look at this problem. It looks pretty straightforward. If 3x minus y is 12, so I know that this has to be true. What is the value of 8 to the x power divided by 2 to the y power? So there's two different ways to do this. There's probably multiple ways, but the two that come to mind are, I first like to, the thing I do a lot, I like to pick my own numbers. So I'm going to try to come up with some numbers to make this thing here true. So let me just kind of think about this. I need it to come out to be 12. And if I pick some numbers, the first number that popped in my head was, 3 times 4, take away 0. I know that's 12. Somebody else might have said, well, wait a minute. I'm going to do, 3 times 5, which would be 15, take away 3 is 12. So this guy or girl would have said x equals 5, y equals 3. But the first thing that came to my mind was x equals 4 and y equals 0. Either way, it doesn't matter. Whichever way you want to go, it doesn't matter one bit. I now have to use my numbers to find out what the answer to this is. So let's check it out. This person would have said, well, 8 to the x power divided by 2 to the 0 power. This person over here would have said, well, wait a minute, this is 8 to the 5th power divided by 2 to the y power. And either way, they both are going to come out to be the same answer. Mine was a little bit smaller, the 4 and 0, because the numbers are a little bit smaller. So let's kind of crank this out. Well, 2 to the 0 power, here's a rule. Anything to the 0 power is 1. I don't care how nasty the algebra expression is. You could have something like this. I'm just making up something, you know, all over t to the 4th. But if you do that and put it to the 0 power, it's just 1. So that's kind of a little fact that you need to have. So I know this comes out to just be 8 to the 4th power divided by 1, which is 8 to the 4th power. My problem is I go over here and I don't see 8 to the 4th power. I can eliminate though. It's not 8 squared, you know, for sure. And it's definitely not 4 to the 4th power, because 8 to the 4th power is 8 times 8 times, you know, this number right here is really 8 times 8 times 8 times 8. Now, I wish I had a calculator, or I could use a calculator. I would just punch it in and I'd get a big old answer. But I know it's not these two. So now I kind of have it down to, you know, is it A or is it D? That's the question. And D seems kind of a cop-out. You know, the value cannot be determined. So I'm kind of thinking it's A, but, you know, I would have to multiply these out right now to know for sure. And maybe I would just do that. Maybe I would just start working down and say, you know, 2 to the 1st is 2, 2 squared is 4, 2 to the 3rd is 2 times 2 times 2, which is 8. And this basically keeps doubling. So 2 to the 4th would be 16, 2 to the 5th, 32, 2 to the 6th, 64. And man, you could get there, but you're going to keep on working your butt off, and your mental math will have to be pretty good to get all the way down there. And then you'd have to multiply these 8s out to see what answer that is. But you could get there if you wanted to go down that road long enough. I'm not going to bore you with a bunch of mental math. So I'm going to kind of skip to probably the more not traditional, but maybe the more sophisticated way of doing this. And that's trying to get powers to have the same base. So recall that when you divide powers, let me just make up a thought bubble, kind of a what if type of problem over here, where, you know, let's say that, you know, x to the 6th divided by x squared. You know, what does that come out to be? Well, when you divide powers, what you're supposed to do is you're supposed to subtract the exponents. You know, so the correct answer is x to the 4th. A lot of people might think that you divide these and get x to the 3rd, but that would be wrong. The proper exponent rule is when you divide powers, you subtract the exponents. Now, I'm only allowed to subtract those exponents, though, if my bases are the same. So remember, like when I say x squared, this is the base, and this is the exponent. So I need to get my bases to match. Well, over here, I can get those bases to match because 2 to the y, I can write 8 as a power of 2. You know, 8 is really just 2 to the 3rd power. So I'm going to rewrite 8 as 2 to the 3rd power. And that's, so now we have 8 to the x. All right. Now, there's one more layer here. This is a little complicated, but whenever you raise a power to a power, so here was dividing powers. Whenever you raise a power to the power, so for instance, like x to the 3rd raised to the 4th, when you take a power and you raise it to a power, you multiply the exponents. So this would be x to the, whoa, I don't know why I put equals there. That would be x to the 12th power. So raise a power to a power, you multiply. So when I come over here, this is really 2 to the 3 times x, or 2 to the 3x. And this one is 2 to the y. All right? So now I have those two, and I'm like, well, wait a minute. 2 to the 3x and 2 to the y, since I have the same base and I want to divide, I really just subtract the top exponent minus the bottom exponent. Well, then it kind of comes into play. Well, that's why they told me what 3x minus y equals. Because 3x minus y is really just 12. And that's how I find out that A really was the correct answer. So knowing that little trick of being able to make bases match up is pretty important. You know, I've seen it with other numbers. It's usually with 2 or 3. They don't usually go too big on the numbers, but I've seen them have something like maybe, you know, they could write like 9 to the x and then 3 to the y. And if I wanted to get those bases, so this is just a what if, you know, the problem's over. I'm just kind of doing a what if here. I know that I can rewrite 9 as 3 squared, so that's my 9. And then my x goes there, my 3y goes here, and a power raised to a power I multiply, so that's really 3 to the 2x, and divided by 3 to the y. And now a power divided by a power, I subtract exponents, and I could write the entire expression like that. So kind of a sophisticated trick that, you know, if you want to get all these problems right and you want to crack up into the 700s and even possibly 800, you need to be able to kind of know some advanced moves like that. All right, last problem here on the no calculator multiple choice part, number 15. Looks like I'm multiplying a couple binomials, so make sure that you understand how to multiply binomials, or you know how FOIL works. FOIL is an acronym for first, outside, inside, last. I have another video where I kind of break down multiplying binomials and give you a chance to practice some problems. But know how they work. I'll talk about it a little bit here, but I'll go into more depth in that other concept video. So it basically says if ax plus 2 multiplied by bx plus 7 equals 15x squared plus cx plus 14, and then they talk about a plus b equal 8, what are 2 possible values for c? There is a lot going on in this question. So the first thing I want to get to is this. I know that when I multiply 2 pieces, all right, if that's going to come out to be 15x squared, and let's just deal with the plus 14 because these 2 pieces are important. The first term is created by the 2 first terms here when I multiply those first 2 numbers together. The last term comes from the back 2 numbers, which I know. They give me the answer to those. They said plus 2 and plus 7. Now the middle term is basically when you multiply the outside numbers and the inside numbers, they come together to give you the x term. Well, let me just think about this. When I see this 15x squared, the very first thing that pops into my head to make 15 are 3 and 5. So right away I'm thinking, well, let's try 3x and let's try 5x and let's just see what happens. All right. So when I multiply this thing out, I get 3x times 5x, which is my 15x squared. That's why I chose those 2. Now for my inside terms, my x terms, I'm going to do the 3x times the 7, which is 21x. And then I'm going to do the 2 times the 5, which is 10x. So when I combine those like terms, that would be plus 31x. And then when I do the 2 times the 7, I get 14, but I already knew that from the beginning. So in this problem, my answer looks a lot like their answer, except for C, I got 31. All right? And they told me this a plus b had to be 8. So the number in front of x and the number in front of x had to come out to be 8, and mine do that. I have 3 plus 5, so my 3 and my 5 come out to be 8. And when I peek over here and I look at my answers, hey, I see a 31 right here. You know, there's C in front of the x. They want to know what are the values for C. I see it right there. So right away I think it's D. I'm pretty confident. Now the only other thing is, where did this 41 come from? How could that happen? Well, that could happen if I would have decided to maybe put the 5 in the front. You know, so instead of starting off with 3x, maybe I put the 5 there. Because you might have wondered, why did he put the 3 first? You know, if you would have did it the other way, and you would have switched the 2, you know, that would have still came out to be 15x squared. But now I would have had 6x, and I would have had 35x, which combining like terms would give me 41x. And then my 2 and my 7 would be the 14 on the end. And I would have got a different answer a little bit, and that's where the 41 came from. Okay, so those are the two possibilities to get 31 and 41. You know, had they not have given me this clue, I might have thought that I could have did 15x times 1x, because that's another way to get 15x squared. But the problem with that is what was in the A position and the B position, 15 plus 1, they told me A plus B had to be 8. And that would have been 16. That would have not worked. So I knew I couldn't start with 15 and 1. I knew it had to be a 3 and a 5. So not too bad, really. I've seen worse for the last question on the no calculator, but not too bad. But again, if you need some review on multiplying binomials, you may want to check out a video, because in that video I show you another method. If you've taken a science class and you've done Punnett squares with dominant and recessive genes, or if you're a younger kid in everyday math, which I had to kind of go back and relearn because I'm kind of old school, but everyday math, they had the lattice method. It's kind of similar to that. I'll just show you really quick for this problem. So 3x plus, if I want to simulate how to do 3x plus 2 and 5x plus 7, and you're kind of struggling with FOIL, you're struggling with this double distribution, you get a lot of arrows, it gets kind of confusing. Another way to do it is do the 3x positive 2 on the top, and then run the 5x plus 7 on the bottom. And now you just have to make sure that every column and every row gets multiplied together. So this box would be the 3x times the 5x. This box is the 2 times the 5. This box would be the 3x and the 7, which is 21x. And this box would represent this row and this column. And then you can combine like terms. You know, I only have one x squared term. I only have one constant or number term. And then here, these two can kind of go together, and I can combine those and call it 31x. So it's just another way, but sometimes it's easier because you make sure you're multiplying the right people, because I've seen a lot of crazy stuff that kids make mistakes, and sometimes that box helps some of them. So could be another little thing helpful for you. Number 16, no calculator. If t is greater than 0 and t squared minus 4 equals 0, what is the value of t? All right, well, first thing, I know I'm solving an equation here, and the first thing I notice is that it has a power of 2. It's t squared. So there's a couple different ways you can deal with this. Normally with quadratics, your options are, you can take the square root of both sides if there's not a linear term, if there's not like a t term in this case. There's a t squared, but there's no t, so I think I could take the square root of both sides. Another option would be I would try to factor this thing and come up with the factors and use the zero product property. And then if I can't do either of those, I will probably use a quadratic formula. There's other times I may want to complete the square, but usually you can factor or you can use square roots. So I'm going to show you a couple different ways. First thing I'm going to do is I see that there's no t term. What I mean by that is, like, if it said t squared plus 4t minus 4 equals 0, then there would be a t term, and I would not be able to take the square root of both sides. But since I just see the t squared, I'm going to go ahead and I'm going to solve it for t squared. I'm going to add 4 to both sides, and I get t squared equals 4. And now, to get rid of that squared, I'm going to take the square root of both sides. And then I got to remember, anytime I take the square root of a number, there are always two possibilities. My answers are positive or negative 2. And the reason being for that is because negative 2 times itself is 4, and positive 2 times itself is 4. Now the only thing was, it said if t is greater than 0. So I know t must be larger than 0. So that wipes out the negative answer. So it looks like t equals 2 is a solution. Another way you could do that is you could factor. And you could look at this thing and say, well, how do I get t squared minus 4? And you can watch, I have another factoring video that if your factoring needs a little bit of work, you could go watch that video and do some practice questions. But t squared minus 4 can be broken down into t plus 2 and t minus 2. This is called the difference of squares. And the reason why that works is because when I do FOIL or I do double distribution, I would get t squared plus 2t minus 2t, which those two cancel each other out, subtract 4, and it would work out for me. And now I use the zero product property, which basically says that if something times something else equals 0, one of the two things are true. Either t plus 2 ended up being 0, or t minus 2 ended up being 0. So you kind of have to solve two cases. And solving this case on the left, when I subtract 2 from both sides, I get t equals negative 2. And solving this one, I get t equals positive 2. And because it said t was greater than 0, this is the only answer that I have. So I honestly think taking the square root of both sides was definitely the easier option on that one. Number 17 looks like a little geometry problem here. It says a summer camp counselor wants to find the length x in feet across a lake, represented in the sketch above. The lengths represented by AB, EB, BD, and CD were determined to be 1800, 1400, 700, and 800, respectively. That word's pretty important there. The word respectively means in the same order. So if they mentioned AB first, then that would be the first number they give. So AB is 1800. I'm going to draw that on the line. The next thing they mention is that EB is 1400. And then they talk about BD, which is 700. So BD, which is 700. And then finally, CD, which is 800. So CD, which is 800. I don't know, missed a 0 there. All right, and then they want me to find what is the value of x. So I'm trying to figure out what the heck this length over here, x, is. Looking at this problem, it looks to me like it's going to be a similar triangle problem. One thing I notice, I wish that squiggly lake line wasn't there. It might be a little more clear. But I do notice this arc mark right here on E and this arc mark on D, which tells me those two angles are congruent. Congruent, remember, just means that they have, if I could spell the word equal length. Or in this case, equal measure. Those angles are equal to each other. And if those two angles are equal, I also know that anytime two lines cross, the angles that are opposite each other, those two are also equal. And then this obtuse angle here would equal this obtuse angle. And they're called vertical angles. So that's kind of a geometry term. Vertical angles are always congruent. So I know that this angle and this angle are equal to each other. They form a bow tie. I kind of think of it as. Well, if these two angles in this small triangle are equal to two angles in the big triangle, the third angles have to match up. 1, 2, 3 has to match up with 1, 2, 3. And now I can do what's called setting up a proportion. I could set up a proportion, and I want to try to get sides that match with each other. And the idea is, if I can set up a proportion with 4 numbers, one of them being x, I think that I can cross multiply to solve this thing. So if you notice, if you look at x, and I say, well, who pairs up with x? Which side in the smaller triangle? Well, x is between, it's on this line that runs between the 3 arc and the 1 arc. So over here, that would match up with this line, the 3 arc and the 1 arc. So I know x corresponds with 800. Now, x was the big triangle, and 800 was on the small triangle. I have to keep that ratio the same on the right-hand side, so I have to put a big side that corresponds or that's in the same position as the small side. So let me get another pair of numbers. You know, it looks like I need another big. I have this 1400, which is between the 1 arc and the 2 arc. So in the small triangle, it looks like 700 is between the 1 arc and the 200. So 700 and 1400 go together as well. So I put the big over the little. And now I have a proportion that we can solve. Now, there's two ways to solve this proportion. There's kind of a super fast way, and then there's a slower way. In general, you always want to cross multiply. So in general, I want to cross multiply and set up an equation and say 700x equals, and 8 times 14, that's 80, and 32, that's 112 with 4 zeros afterward. And now I would simply divide both sides by 700 and divide both sides by 700. And I end up getting an answer of 1600. Now I always want to go back and say, does that really make sense? So let's look over here. Does that make sense with my picture? And I think it does. And the reason why it makes sense is if I go back up here to my proportion, before I cross multiplied, I might have kind of saw that these numbers were a little bit friendly. This ratio over here on the right, that top number was exactly 2 times larger than the bottom. So I could have just said, hey, this side's got to be 2 times larger than the bottom. And I could have kind of avoided all of this algebra work over here if I didn't want to deal with those big numbers. So proportions are kind of nice problems that you always, whenever I see a geometry problem with a small triangle and a big triangle, you are always going to set up this, either big over little, or little over big, little over big. All right, number 18. Looks like this is the second time on this test that a system of equations has came up. So already 2 out of the first 18 questions. So that kind of tells you it's an important topic that shows up over and over and over. So as according to the system of equations above, what is the value of x? So be careful. There's 2 answers. There's x and y. This time they want x. I don't have choices like I did on the multiple choice part, so I can't just plug answers in. This one I actually have to solve. And this is a great candidate for elimination. If you're unsure what elimination is, you can watch my system of equations videos as a method of solving this system. But basically I'm trying to get my letters lined up. I have my x's here, I have my y's here, I have my numbers here, so everything looks great. And now I have a choice. I can either add or I can subtract those 2 equations to eliminate one of the letters. And right there's kind of 2 routes you can go. Right now it's set up right now to subtract, and I would eliminate, but I would eliminate the x. I'm going to go ahead and do that anyway to show you how you could still solve it. So if I subtract these 2 equations, x take away x is gone, that would be 0. 1y subtract 2y would be negative 1y. And now I got to be careful with these numbers here. I have a negative 9 subtract a negative 25. I never subtract, I always add the opposite. So that comes out to be 16. And dividing both sides by negative 1, I end up with y equals negative 16. Now that's not the answer. Okay, that's not my final answer. I need x. So I could go back up here, and either equation, whatever one I prefer, I can substitute or plug negative 16 in for y. I'm going to do it for the first one because it looks a little bit smaller, a little bit more simple. So x plus a negative 16 equals negative 9. And now to get that x by itself, I'm going to add the 16 to both sides. And I end up with x equals 7. And I think that should work in both equations. I could plug 7 in, and I could plug negative 16 in and see. I think it works down here as well. 7 plus 2 times the negative 16. Yep, that is 25. So my final answer is x equals 7. Now, some people may have done that a tad bit differently. Some people may have said that, why would I eliminate x's if I'm looking for x? So they might have decided to make the y's match up. Right now I have 1 y right here and I have 2 y's here, and I need to get those to match. So I could just multiply this top row by a factor of 2. So multiplying the top row, I would get 2x plus 2y equals negative 9. The bottom row is just x plus 2y equals negative 25. And now I have a decision to make. Do I add or do I subtract? Well, if I want the y terms to go away, I would not want to add, because 2 plus 2 would be 4y. I'm going to subtract. So 2x subtract 1x is x. 2y subtract 2y is 0. And now negative 9 minus a negative 25. Again, don't subtract, add the opposite. And this time I would have got my answer without having to plug anything back in, because I chose to eliminate the other letter. So 2 different ways to do it, your choice. All right, number 19, looks like we got a little bit of trig here. I see some sine and cosine. In a right triangle, one angle measures x degrees, where the sine of x is 4 over 5. So that's kind of my first clue. So I know I have a right triangle. So let's see what we have here. A right triangle, which means there's a 90-degree angle in it. One angle measures x. So there we go. And the sine of x is 4 over 5. They give me that. And then they want to know, what is the cosine of 90 minus x? Well, and you don't have a calculator. So this one seems a little bit tricky. Let me go on a bigger slide where I have a little bit more room. Let's see if we can break this one down. So let's start off. I have a right triangle. And if this is 90 degrees, one thing I know is that the other 2 angles have to add up to 90 degrees, because all triangles equal 180 degrees. And so if this is 90 right here, and this one is x, this other angle here has to be 90 take away x. Okay? Because that relationship, let's just pretend, this isn't true, but let's pretend that x equaled, 30 degrees. Then that means if I put 30 degrees in right there, 90 minus 30 would be 60. And now I would have 180 degrees, because I have my right angle, I have the top angle, and then I have that bottom angle. And so basically that 90 minus x forces the triangle to add up to 180. So that's one important piece that you need here. The other important piece is, for all trig problems, you need to understand the mnemonic device called SOHCAHTOA. And a lot of you guys learn this towards the end of geometry class, or maybe in advanced algebra or algebra 2, pre-calculus. All those courses talk about the trigonometry ratios, but it's an acronym that stands for the sine of an angle is the opposite leg over the hypotenuse, and the cosine of an angle is the adjacent leg over hypotenuse, and the tangent is the opposite leg over the adjacent leg. Now let's talk about this a little bit. So for this problem, they told me that the sine of x degrees, or the sine when standing on x degrees, is 4 over 5. So let's kind of break that down a little bit. I drew the triangle and I put x up there at the top. So x is what's called my reference angle. So x is where my point of view is. So I'm standing up here. Sometimes I even like to draw a person. I'm standing up there on x, and I'm looking out across the triangle. Well, I know that the sine ratio is the opposite leg over the hypotenuse. Well, let's start with the hypotenuse. The hypotenuse of any right triangle is basically this side opposite the 90-degree angle. It's the slanted side, but more importantly, it's always opposite the 90. So that's the hypotenuse. So I know that this side, put a little fatter, this side is 5. So that's my hypotenuse. Now, according to this guy, the opposite leg is the leg that's across from me. So right here, this represents the opposite leg, and in our formula here, the opposite leg was 4. That's the top number. So my 4 goes right here. Now, I don't really need the adjacent leg, the leg that's right next to me, which is this leg over here. I don't really need that, but I could use a Pythagorean triple that I know always works. That's 3, 4, 5. 3, 4, 5 is a Pythagorean triple that always works. 3 squared plus 4 squared is 5 squared. But I don't really need that 3, but I just thought I'd sneak that in there. So I've used their clue to draw the triangle. They gave me this information. I now have the sides 4 and 5 labeled on the triangle. And then they finally said, hey, what is the cosine of 90 minus x? All right, what is that? Well, so now my point of reference has changed. Now I'm no longer standing on x. All right, whoop, I'm going to put that 4 back on there. And I'm no longer standing on x, but my reference angle is 90 minus x. So now I'm standing down here looking out across the triangle. Well, 5 is still the hypotenuse. The hypotenuse never changes position. It's always across from the 90. But my opposite leg now has changed and my adjacent leg has changed. Since they're looking for the cosine, I need to come up with this ratio, adjacent over hypotenuse. Well, the hypotenuse I already have. It's 5. Now the adjacent leg, according to this person's point of view, would be this leg right here. It's the one right next to me. So it looks like the cosine of 90 minus x, the answer is the exact same as the sine of x. Now that was a long kind of drawn out way that you had to know the trig ratios, but there's actually a shortcut, and there usually is on the SAT. There's usually a shortcut if you know some deeper knowledge. So the big time shortcut is this. It's always true that if two angles are complements, so complements mean that, something plus something equals 90 degrees. That's what complements are. Well, two complements, so say for instance, 32 degrees, and the other one, let's say, is, what's that come out to be 90? That would be 58 degrees. These two numbers are complements. It's true that the sine of one number is always going to be equal to the cosine of the complement of that number. All right, that's a fact that's always going to be true. You can punch it in your calculator, you can look on a trig table, but as long as these two numbers add up to 90 degrees, the sine of one is going to equal the cosine of the other. So I could pick another number and I could say, hey, how about the sine of 74 degrees? Well, I don't know exactly what the sine of 74 degrees is, but I do know it's equal to the cosine of his complement, or 16 degrees. And notice you get this number by going 90 minus 74, which in our problem here, since this was x, this was 90 minus x. So it was kind of a trick question if you knew a little bit of deeper knowledge. So hopefully if you see that one again, you'll be able to sidestep a lot of the trig and just apply that little relationship. All right, last question on the no calculator portion, number 20. Usually number 20 is going to be a little bit tougher, so I'm expecting a battle here. Looks like we have some square roots we have to deal with. Looks like algebra. So let's get after it. If a equals 5 radical 2 and 2a's equal radical 2x, what is the value of x? So we have to solve. One thing I see is that if they tell me what a equals, I know a equals that, I can substitute that value in wherever I see an a. So I'm going to rewrite this equation right here, but I'm going to replace a with 5 radical 2. So 2 times 5 radical 2, same thing as 2a, equals radical 2x, or the square root of 2x. I usually just say radical. Now I got to break down a couple things for you. So kind of some scratch work over here off to the side. First off, you can multiply a radical times a radical. For instance, if I want to know what radical 5 times radical 7 is, I can multiply those together and call it radical 35. All right. I can divide radicals. If I want to do like the radical 20 divided by a radical 4, the correct answer to that is radical 5. I'm allowed to do that. Now, one thing that I'm not allowed to do is I cannot add or subtract radicals. So I could not say radical 5 plus radical 7 and is radical 12. That would not be, I can't use that rule. That's not allowed. So that's something that you can't do. Now, if you have numbers on the outside, for instance, you have like 2 radical 5 multiplied by 3 radical 6, let's say. Well, I have to multiply this piece by piece. So the number on the outside, this coefficient here, I can multiply the 2 times the 3 and get 6. And then I can multiply the radical 5 times radical 6 and get radical 30. So that's how I'm going to have to do these multiplication problems. Is I have to handle the numbers on the outside different than the numbers on the inside. You know, they kind of go together. So looking over here to the right, let me show you what I mean, kind of why I did this scratch work. I'm multiplying 2 times 5 radical 2. So I can multiply the 2 times 5 together and get 10 radical 2. Over here, this is radical 2x. I'm not doing anything there. So basically, I've just doubled 5 radical 2. Now, in order to clear out radicals, you know, in order to get rid of a radical, the opposite of taking the square root of something is to square something. So my next move to both sides, I'm going to multiply this side by itself, and I'm going to multiply this side by itself. Because the beauty of doing that is, if I do something like the square root of 2 multiplied by itself, that ends up being the square root of 4, which is really just 2. So whenever you multiply a square root by itself, the answer is just that inside number. That's kind of a rule that always happens, so we could generalize and say radical x times radical x is equal to just x. So I'm going to use that fact over here. So let's take all these pieces to the second power. So let's do the 10 first. 10 to the second power times radical 2 to the second power. And that's going to equal radical 2x times itself. Okay, I could have wrote squared, but I'm just going to multiply it by itself. So let's do this. Let's go through and let's clean this thing up. Well, 10 squared is 100. Radical 2 times radical 2 is radical 4, which is just 2. I can apply the rule, you know, that we used up here. And then on this side, the square root of 2x times the square root of 2x is just equal to 2x. Now, if you're unsure about that, you could multiply it out and find the square root of 4x squared. But the square root of 4 is just 2, and the square root of x squared is just x, so there was really no need to multiply. Now things look pretty nice. I have 200 equals 2x, and I'm going to divide both sides by 2, and I find out that x equals 100. And if you plug that back in, it should work out for you if you double check it. I really don't have another way of doing this problem. Nothing really jumps into my mind, a clever trick or another way to do it. Pretty much you just have to know how to multiply radicals, and the big thing was you had to know that to clear out a square root, you have to square both sides of the equation.